Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0141 refers to a malfunction in the rear secondary heated oxygen sensor HO2S heater circuit, specifically located at Bank 1, Sensor 2 of the Honda Odyssey models from 2011 to 2017. In internal combustion engines, oxygen sensors are critical for the proper functioning of the fuel injection system and are instrumental in monitoring the fuel mixture entering the engine. The rear secondary HO2S, also known as Bank 1 Sensor 2, is primarily responsible for measuring the oxygen levels in the exhaust gases, which helps the engine control module, ECM, to adjust the fuel-air mixture for optimal combustion. In this scenario, the sensor's heater circuit, which ensures the sensor operates at the appropriate temperature for effective readings, appears faulty. This could lead to increased emissions and poor engine performance. It's important to note that the second code, P0161, indicates a similar condition for the front secondary HO2S at Bank 2, indicating there may be systemic issues present that could affect both sensors. Comprehensive diagnostics are necessary to identify the underlying causes of these error codes. The rear secondary heated oxygen sensor, or HO2S, plays a crucial role in ensuring proper fuel management within the Honda Odyssey's engine. Located in the exhaust system at Bank 1, specifically as the second sensor downstream from the engine, it evaluates the amount of unburned oxygen in the exhaust gases. This analysis helps the engine control module, ECM, adjust fuel delivery to optimize fuel efficiency and reduce emissions. The heater circuit within the HO2S is vital for reaching the operational temperature quickly, enabling accurate readings shortly after the engine starts. When the diagnostic code P0141 is triggered, it signifies a malfunction in this heater circuit. Such a failure may lead to prolonged low fuel efficiency and increased harmful emissions, violating regulations and potentially affecting vehicle performance. The importance of having this sensor functioning correctly underlines the need for proper diagnosis and repair to maintain the vehicle's overall environmental compliance and operational integrity. Several possible causes can lead to the triggering of DTC P0141 for the rear secondary HO2S. Firstly, a faulty heater circuit within the HO2S can prevent it from reaching the necessary operational temperature, leading to incorrect readings and poor engine management. The PGM-FI relay responsible for supplying power to the fuel injection system and related components could also be defective, which impacts the operation of the HO2S. Additionally, a blown fuse, specifically the number B8FI sub 15A fuse located in the underhood fuse/relay box, can disrupt the circuit flow required for the sensor's operation. Wiring issues, such as frayed wires or exposed conductors, can create intermittent connections that might mimic sensor failure. Lastly, poor electrical connections at the sensor, relay, or powertrain control module, PCM, can lead to unreliable performance. Identifying and addressing these causes is crucial for resolving the DTC effectively. When DTC P0141 is present, various symptoms may manifest as indications of underlying issues with the rear secondary HO2S. The most immediate symptom is the illumination of the check engine light on the vehicle's dashboard, signaling to the driver that a diagnostic issue has been identified. This can coincide with poor fuel economy, as the engine may struggle to adjust its mixture correctly without proper feedback from the HO2S. Furthermore, increased emissions can occur as the vehicle fails to optimize combustion, potentially leading to environmental regulatory failures. Drivers may also experience rough engine performance, particularly during idling or acceleration, indicating mismanagement of fuel delivery. In many regions, this issue may result in failing emissions tests conducted for vehicle inspections. Recognizing these symptoms early can prevent further complications and more extensive repairs. Begin the troubleshooting process by turning the ignition switch to the on position, 2, without starting the engine. This action powers up the vehicle's electrical systems, including diagnostic systems, which enables the technician to assess any present error codes. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs from the vehicle's memory. Clearing the DTCs is essential for determining if they will reappear as the vehicle operates, providing valuable information about the nature of the fault. After clearing the codes, start the engine and allow it to run for a moment. This step is critical as it enables the sensors, including the HO2S, to start functioning and potentially trigger any pending DTCs that weren't present during the initial scan. Finally, check the HDS once again for any pending or confirmed DTCs. If DTC P0141 or P0161 reappears, this signifies a continued issue that requires further investigation. After confirming the presence of DTC P0141 or P0161, the next step involves turning the ignition switch to the lock position, 0, to ensure safety while working on electrical components. The technician should then locate the number B8 FI subfuse, which is a 15-amp fuse housed in the underhood fuse/relay box. This particular fuse is essential as it protects the circuits involved with the fuel injection system and various sensors, including the oxygen sensors. Use a multimeter to check the state of the fuse to determine whether it is intact or blown. A blown fuse can signify excessive current draw from a fault elsewhere in the circuit, necessitating further inspections. If the fuse checks out and is functioning correctly, the troubleshooting can continue to the next stages of the diagnosis, verifying the ongoing functionality of associated components. Once the fuse has been checked and verified, the technician should remove the PGM-FI sub-relay A from the underhood fuse/relay box. The PGM-FI relay is crucial as it controls the power to the fuel injection system and other related electronics, including the oxygen sensor heater circuits. After removal, conduct a test of the relay using a multimeter to ensure it is functioning correctly. A proper relay should have a specific resistance value indicated in the service manual. If the relay fails this test and does not conduct as expected, it should be replaced to restore the circuit's integrity. Verifying the state of the relay is important, as a defective relay could lead to symptoms similar to those of a faulty HO2S and can directly contribute to the persistence of DTC P0141 if left unaddressed. The next critical troubleshooting step involves disconnecting the 4-pin connector of the secondary HO2S, also known as sensor 2. This step allows for direct inspection of the wiring and connectors leading to the sensor. Inspect the wiring for any signs of fraying, insulation damage, or corrosion that could lead to intermittent or complete circuit failures. Additionally, check the connectors for proper seating, signs of corrosion, or broken pins, as they could impede electrical flow. It is important to look for short circuits, which could occur if the wiring is exposed and contacting grounded metal surfaces. Continuity tests can also be performed to ensure that signals can flow from the sensor to the ECM. Addressing any issues found during this inspection is essential, as any faults in this area can directly contribute to the sensor malfunction indicated by DTC P0141. After performing the necessary repairs based on the previous steps, it is essential to verify that all actions taken have resolved the issue effectively. Begin by using the Honda Diagnostic System, HDS, to clear any DTCs from the vehicle's memory. This step ensures that the system starts fresh and allows for an accurate assessment of function post-repair. Following this, conduct a test drive under typical operating conditions to allow the system to recalibrate and assess if the repairs have worked effectively. Finally, after the test drive, check the HDS again to confirm that DTC P0141 and any other previously noted codes do not reappear. This step is crucial as it assures the technician that the faults have been resolved and that the sensor and its associated circuitry are functioning correctly. Preventive maintenance is crucial in ensuring that issues like DTC P0141 do not arise frequently, and that the vehicle's exhaust and emission systems remain efficient. Regular checks of the wiring related to the oxygen sensors can help identify potential damage before it leads to malfunction. Monitoring sensor performance by keeping an eye on fuel economy and emissions can provide early warning signs of wear or impending failure. Additionally, routinely checking the integrity of related fuses and relays ensures that electrical current flows properly to components like the HO2S. Inspecting connectors for signs of corrosion or loose connections can also mitigate issues that may lead to false readings. By adhering to these preventive steps, the longevity and reliability of the vehicle's emission control system can be significantly improved. In summary, DTC P0141 signifies a malfunction in the rear secondary HO2S heater circuit, which is critical for accurate emissions control and engine performance. The troubleshooting steps involve a systematic approach that includes checking the ignition system, inspecting fuses, testing relays, and examining the sensor's wiring. By ensuring that each component is in proper working order, technicians can effectively address this error code and restore optimal vehicle function. Moreover, proactive preventive maintenance measures can help avoid future occurrences of similar DTCs, ensuring the Honda Odyssey operates within its designed emission standards. Ultimately, prioritizing accurate diagnostics and timely repairs will lead to better fuel efficiency, reduced emissions, and smoother engine performance. Please like and subscribe to the channel. See you next time.